Today we're going to be talking about quadratic functions and data. So we've talked about data a little bit before when we were doing scatter plots and finding line of best fit. So we're going to do kind of something similar, but today we're going to talk about how to take points into put it in the calculator and find a line of best fit, and then use that line to help us answer some questions. So when given data that follows a parabolic trend, we can use technology to write quadratic functions that best fit the data. Use each of the following situations to write quadratic functions, then observe how they can be used to make predictions and interpret the data. So that's pretty much the basis of what we're going to do. I'm going to use scenario 1. Scenario 2 and scenario 3 are going to be your independent practice today, and then your exit ticket will have another scenario as well. So, number 1, Taylor attended a concert with her friends. During the concert, the singer threw a t-shirt from the stage and into the crowd. The table below shows the height of the t-shirt, h of x, at different horizontal distances from the stage. So using technology, input the table values and find the values of A, B, and C. So the steps of what we're about to do are very similar to how we found line of best fit with linear equations, linear regression. I don't know if you remember that. But what I would do right now is pause this video, write down the table so you can put these points in. But I'm going to go ahead and switch over to my calculator. Now this is not as nice of a calculator. There's some features that are missing, including the button that I need, or the menu that I need. So I'm going to try to step you through the steps as much as I can, or mirror the steps as much as I can here. So our first step is going to be to hit the stat button. It's right here next to the variable button. You've got second alpha. If you look at the green button, go 2 buttons over, and that's stat. Once you've hit stat, you can hit enter or 1, because we're going to enter or edit the list. We're going to create our table. So remember that your first variable goes in the first column and your second variable goes in the second one. So we have 1, 3, 5, 7, 9. Enter those in. 3.92, 5.28, 6, 6.08, and 5.52. So now that we have entered the tables, we're going to go calculate. Now we know that this is a quadratic function because we're dealing with quadratics. So this is where we get a little issue. On your calculator, you're going to hit stat again. You're going to hit the right arrow button to where it says calculate. Now, if you see on my screen, I only have 3 options, 1, 4, and 8. You're looking for option number 5, where it says quad reg. That is a quadratic regression. You're going to hit enter. So if this was quadratic regression, say I'm looking at 4, this is linear, so it's going to give me a linear line of best fit, which is not what we need. You want 5 quadratic regression. But I want to show you, just as if it was a linear regression where we have the ax plus b format, it gives you some options, and you would hit enter, and then it would calculate. And so on the side, it should give you a function of ax squared plus bx plus c, and then it'll give you the values for a, b, and c. Like if I did the linear regression here, it gave me the value for a and b, and just like it showed me what my formatting is. So you're going to do the same thing, but you're going to use, when you go to stat, calculate, you can hit 5, or you can scroll down to hit and enter at 5, but you want quadratic regression. You're going to arrow down and then hit calculate, or when it's highlighted over calculate, hit enter, and then those will give you the variables for A, B, and C. So if you did that correctly, your variables for A, B, and C should be negative 0.08, 1, and 3. If you did not get that, or did not get those numbers, I would go ahead and stop and ask your teacher to make sure you did not, or you understand how to put it in the calculator. So using the values above, we're going to write a quadratic function to represent the data in standard form. Remember, this is the f of x. Well, in this scenario, it's h of x. In standard form, equals ax squared plus bx plus c. And we have our a, b, and c now with negative 0.08, don't know what 8 that is, 8x squared plus x, just because my variable, my b is 1, I'm not going to write it, plus 3. This is equal to h of x. So that is how to find a quadratic function when given a table. So we've written the function. Now we're going to graph the function. We're going to graph the function from number 2 in your calculator. So go back to our trusty dusty calculator. We're going to hit y equals, and I'm going to put negative 0.08. Variable, that's the one right next to the alpha. So x squared plus x plus 3. So I've now put that in the calculator, so I am going to graph. And if you're looking at our practice document, I want you to notice that we're only looking in quadrant 1. And so I also want to talk to you about how to change the window or what we're looking at. So if you go to window, this is where you can determine what you're actually looking at with the graph. And with us being given a quadrant 1 graph, I'm going to put in the axis based on what the axis of the graph is. So our x values are from 0 to 16. So my x min is going to be 0. My max is going to be 16. And it looks like we're going by, it's counting by 2, but it counts every other line. So I'm going to leave it as a scale of 1. My minimum is 0 for y. And I go up to 7. So this is how I've changed my scale. I'm keeping at 1. So now when I go to graph, I'll see exactly what I want to see to match the graph that we're going to sketch. So a couple of points. We see 0, 3 is 1 point. It looks like our x-intercept is at, okay. Your graph should better show you the scales of counting. Let me go back to my window. I think it's this one. Okay, just crashed. All right, well, that's cool. 0. Oh, 16. 0. 7. Okay, we'll just leave it at that. Oh, it really crashed. Negative 0.08. X squared plus x plus 3. Graph. There we go. So there's a couple points I see, but it looks like 3 and 0, 3 and 15, 0 are pretty much the best points we have. So I'm going to do my best with my artistic ability here. I know that I have a point at 3, 0 and 15, 0. I know that my maximum looks to be about, if I go over 6 and up just past 6 on my y, I'm going to try to about right there. And 4 looks to be about right at about 5.5 half and 10 and 5. So not beautiful, but we're going to try to do our best here. I'm going to go ahead and use a thicker pen mark. Oh wow, that is. So that is a very rough sketch of our graph. So we're going to label the x and y intercepts. And that is x-intercept is where it crosses the x-axis, y-intercept is where it crosses the y-axis. So 0, 3, and 15, 0. It's supposed to be there. I didn't do a very good job of drawing it. Okay, so find the vertex using b over negative 2a. Check your answer with the graph on your calculator. So you can check that by looking at the points. But knowing our vertex, it's going to be kind of around 6, so that should be a good thing. But using our b over 2a, so that's 1 over, so b was 1, and a is negative 0.08. So to find the vertex, would be 1 over negative, well, negative times 2 times negative 0.08. I'm going to go ahead and put that in the calculator so we can see what that's going to look like, if it'll work with me. So I'm going to do negative 1 just to get that negative in there, divided by 2 times negative negative 0.8, enter. That gives us 6.25. Remember, that's the x value of our vertex. This is the x value of our vertex. So our point starts with 6.25. So you can either figure out what the y value is in your table. So once we have it graphed, you can hit second graph, and that gives you the table. And it should tell you how to change the scale on your calculator. There's a button you hit, and you can type in to put it in by, like, if you want by 0.25 or 0.5, you can change how it counts for the table. It's just not letting me do it on this one, but we have another way we can figure this out. So graph, clear. So if that's my x, then I'm going to replace every x in the function with 6.25. So next times 6.25 squared times, nope, that's supposed to be plus 6.25 times 1 plus 3. So my y value is 6.125 in our vertex. So part of the reason why we are learning this today is because not all of the vertex that we're going to deal with, or the quadratic functions that we're going to deal with, turn out to be as nice and neat of numbers as we've been playing with before. So here's our vertex, and you should know that because our a is negative, the vertex is going to be a maximum point. So looking at the graph, I'm hoping your graph looks much nicer than mine. And looking at what we know in the calculator, we're going to apply it. We're going to make predictions using this information. So number 6, we're going to predict the height of a t-shirt when it's in horizontal distance from the stage in 10 meters. So what that means is my x is 10, so we want to know what the y is. So if x is 10, what is the y? So at 10, you can either look at your table, second graph, and look at 10, or you can calculate it like we did to calculate the y value for our vertex, but 10, we have a point of 5. So predict the height of the t-shirt when it's horizontal, so that's the height when x is 10. So if x is 10, then my y is 5, so that's 5 meters. Number 7, describe the meaning of the vertex in the context of the situation. So if we're talking about what the vertex is, what does that mean? Well, it's the maximum. And if it's our max, when we're looking at our y value, it's the max height. It's the maximum height that it can be thrown. And we get that when it's at a certain distance, or our x value. So to put that in words, the shirt pretty much can reach a maximum height of 6.125, because that's our y value, meters when thrown from a distance of 6.25 meters. So it can reach the maximum height only when it's thrown at this x value, but that is the maximum height possible to throw the shirts. So that is what the vertex means. Number 8 is going to be the last one that we do. We're going to find the domain and range of the function. So domain and range. Normally when we've talked about parabolas and quadratics, we've said that the domain is all real numbers, not all real functions, all real numbers, except when we're given real world scenarios. So most of the scenarios that you're dealing with quadratics and data will most likely have a domain that's not all real numbers. There's going to be a specific one. So if we are looking in quadrant 1, we're really looking at all of the possible x values. So if our domain, looking at 0, is where we start off with, to 15, which is where it crosses 0 again, in our y values, then our domain, all of our possible x's are 0 is greater than or equal to x, which is greater than or equal to 15. Then we have our range. Our range is all our possible y values. So it starts off at 0 is greater than or equal to y, which is greater than or equal to the highest amount of y that we could get, which was 6.125. So that is quadratics, functions, and data. It's pretty simple if you're understanding quadratics so far. I will say, please remember that when you're typing in your domain and range, because we're typing and you don't have access to put in the correct sign for our greater than or equal to, please remember that we are saying or equal to. I know you can only put the greater than sign, but I want you to understand that that is or equal to as well. But if you have any questions, please ask your teacher. Other than that, you can start on your